All right. So for a function to have an inverse, it must be 1-to-1. So it's got to pass the horizontal line test. It says to define the inverse sine function. This is what the last class was doing. It said to define the inverse sine function, we restrict the domain of the sine function to the interval of negative pi over 2, comma pi over 2. Okay. If you're typing in negative 90, comma 90, it's going to give it to you wrong, but you're right. Okay, it's just in the wrong mode. The last class kept typing in negative 1-to-1. Okay, what they were doing was looking at this idea here. If I take, remember we took the sine function, sine of x between like negative, I should say 2a to 2a, and that's just going to allow this thing to kind of stretch. So our sine function is periodic, right? Okay. Right now, that thing fails. That thing fails the horizontal line test in a lot of different places. Okay. So what we try to do is restrict this thing. We try to kind of shave it down, cut it down to the point where right there, it's still failing the horizontal line test, say maybe there, right? So I keep trying to dwindle this a little bit to maybe there, and now as I move that, we pass the horizontal line test, correct? Okay? So that function, so that's what the question is asking. It's saying you take the sine function, the blue curve, and you're going to cut its domain down in negative pi over 2 to pi over 2. Okay? The range is negative 1-to-1, right? So if you answered with negative 1-to-1, my thought is that you were doing this. You were taking maybe a point on there, and you were reflecting it over line y equals x, which is fine. And you were getting, I'm going to move this point A. You were getting that black curve there. That black curve is the sine inverse. Does that make sense? What's the domain of the sine inverse? Negative 1-to-1. Okay? So I think if you're typing in negative 1-to-1, I think you're giving me the domain of that thing. Does that make sense? Which I think then is, in the way I would view that, is that you're kind of maybe reading the question backwards. You're not paying attention to which function they're describing at the beginning. Okay, just be on the lookout for that. Does that help? Okay.
I know we did brackets. I thought we don't like the greater than stuff like that.
So you put it in set builder notation.
Yeah.
You went negative pi over 2 is less than. What did you use as your variable?
I didn't put a variable. That's why I was confused.
Okay. All right. So if, in situations where you're not certain what to use as your variable, maybe that is an identifier to use interval notation. Interval notation is predominantly the notation that gets used. So that's kind of your go-to, just in future reference. Any others on here?
Number two.
Two?
I need more tests on this one.
All right, so the inverse sine. Okay, so the function sine inverse. So this is actually now talking about that black curve. Okay? So if I look at that black curve, which is sine inverse, okay, and I look at the way I've structured this. Let me mess around with these x-axes real quick. Let's go x-axis in terms of integers, y-axis in terms of pi over 2. So we can do that, okay? So if I'm looking at the sine inverse, what's the x value that this thing is defined for? Negative 1-to-1. So that's what we're looking at when it says the sine inverse has a domain. We type in negative 1-to-1. And the range, which is our y values go from the lowest, negative pi over 2, to positive pi over 2. And that's going to be your range. That make sense? Okay. The tangent function is a little bit different in the fact that the tangent function, okay, remember the tangent looks like this, and so it's periodic, so I'm only going to look at it between negative pi over 2 and pi over 2, okay? Now if I take that thing and I reflect it across the line y equals x real quick, which would be the inverse, right? So let's reflect that thing over y equals x. Now it gives it to me, and GeoGebra is a parametric curve, which we'll talk about later on. But that there is your arc tangent. If I type in arc tangent of x, should go right on top, right? Well, when I had earlier, okay, when I had my asymptotes, my vertical, so let's go back to tangent real quick. And we'll talk in more detail of this later on. But that tangent has asymptotes at pi over 2 and negative pi over 2. So we go x equals pi over 2, for instance. That purple curve will never get to the right of that black line, right? So that's an asymptote. And you can think about that. So that's, pi over 2 is 90 degrees. And what you would have there at 90 degrees is sine divided by cosine. And cosine of 90 degrees is 0. So you'd have 1 divided by 0, essentially, and that's undefined. So that's why we get an asymptote. We'll talk in much more detail in chapter 6 and 7 about that. But if it's a vertical asymptote here, when I reflect it to that, it becomes a horizontal asymptote. Does that make sense? So at pi over 2, that's the largest y value that I'm going to get for my tangent inverse. Negative pi over 2 is the smallest I'm going to get for my tangent inverse. Okay? The domain, though, what do you think? I don't know why. I'm not sure why, but it kind of disappeared. But that was dumb. I don't know what that's doing. Let me type it this way. It might be the parametric. Yep. Is this thing proving a point that it's going to have any x value that we ever want? Okay. So domain for the tangent inverse is all real numbers, and then the range, because of those asymptotes, is negative pi over 2 and pi over 2. And because they're asymptotes, we can't get to them, so that's why we use parentheses there.
You don't even count that right.
That's the dumbest thing I've ever seen.
Pretty much right. Am I wrong? No.
Any others?
No, I think everything else is like that.
7? All right, so find the exact value of each expression. Now and Blaze, this is something that I want to make sure that your eyes are open to. In about 3 or 4 weeks, when we need to be able to use this stuff, and you haven't learned it, and you come crying to me that you don't know how to do it because you refuse to learn it here because you rely on your calculator, I'm not helping you. He's not going to help you either. Okay? When I take away maybe your calculator's functions or your ability to even use your calculator with the questions that I give, you're going to be up a creek. You will be. Okay? So when we're sine inverse, remember what this means here. That's a ratio, correct? And because it's sine, it is what ratio? Opposite of hypotenuse. Okay? And now, so it's sine, and it's negative, right? Okay? Negative radical 2 over 2. Okay? If we remember the sine inverse is only going to give you results that come out of these two quadrants. Does that make sense? Okay. So it does not exist over here. So we would not draw pictures over here. So what quadrant would I need to be in so that my opposite side is a negative, big negative sign? What quadrant do I have to be in so that my opposite sign is negative? Fourth quadrant. Okay? So, fourth quadrant here, and this here is going to be my theta. I don't know. Everything just froze. Now I think I was having a moment. There we go. All right. So there's theta. Okay. Opposite, negative radical 2, right? Hypotenuse, 2. Okay. Pythagorean theorem is going to tell me that I could take this distance here, okay, which is going to be a squared plus negative radical 2 squared equals 4, 2 squared. Okay? So your a squared is going to equal, so that's going to be 2. Subtract that 2 from the 4, I get 2. So doesn't a have to be radical 2? Okay? So if a is radical 2, if that distance is the same as that distance, and this is a right triangle, isn't that a 45, 45, 90 right triangle? Okay? So that tells me that this theta right here is 45 degrees, right? But we're going down, we're going clockwise, so that theta is actually going to be represented as negative 45 degrees or negative pi over 4. Is that all right? Okay. Now, some people might say, well, 7 pi over 4 is also coterminal, right? And if you type in 7 pi over 4, the sine of 7 pi over 4 in your calculator, it's going to give you back the same ratio of negative radical 2 over 2. It's going to give you like 0.707 back, and it'll be negative, okay? But remember what function we're using here. We're using a sine inverse. We're not using a sine function. So the sine inverse, remember, is only going to give you output values that are in this blue here. So I can't say 7 pi over 4, because 7 pi over 4 is not in the range of values from negative pi over 2 to positive pi over 2. Does that make sense? Okay, so there you have to use the negative angle. Okay, cosine. Cosine is the same structure, but where is the cosine negative? Yeah, cosine is going to be negative and 2 and 3. Okay, so these two quadrants were negative. Okay, but the cosine inverse is only ever going to give you something back out of those two quadrants. Okay, cosine inverse is defined only between 0 and pi. This information, kind of coupled together, tells me that I should have a triangle over here. This is going to be the theta. Okay, negative radical 2 is the adjacent side. 2 is the hypotenuse. The same algebra that we did over here is going to tell me that the opposite side is 2, right? Yeah. Sorry, radical 2. Is that a 45, 45, 90 triangle again? Yeah. Okay, so this angle here in degrees would be 45 degrees, right? So how big would theta be? Theta is this angle here. Well, in degrees it would be 135, right? Okay. And if you want to convert, you do need to convert that for this problem. Multiply that by pi over 180, and it'll give you 3 pi over 4. Yes?
So you know how it says, like, cosine and then sine with the negative 1 there? What is that, like, saying? Is that just so we can have a negative on the other side of the equal sign?
No, so you're talking about that superscript negative 1?
Yes.
That is the inverse function. Okay. So when I see that, that tells me that this is a comparison of sides of my triangle. When it's just sine, so no negative 1, that tells me the number that is in there is a angle measurement.
Oh, okay.
So this tells me that this is a ratio, and the output, which in this case is 3 pi over 4, that's an angle.
Okay.
So we talked that we can also use the word arc sine instead of sine inverse. I like writing arc sine and using arc sine because just in the past I know people struggle with that negative one. They think it's an exponent. They think something. They just view it incorrectly. So I like to use arc sine instead. We get to calculus. A lot of times they don't even use sine inverse. They use arc sine. Does that help? All right. Any others you guys want to talk about? Did you guys do okay on number 4?
I did.
Yeah?
Yeah. I thought it was pretty easy.
Well, let's do number 4 because that's going to jump us into the example that I want to go over in our notes from yesterday that we didn't get to. Let's see here. All right, so they're giving us here this is sine of cosine inverse of 9/41. And it says we let cosine inverse of 9/41 and complete the right triangle below. Okay, I don't really care too much for the description here. I want you guys to understand when we look at this. We've got several things kind of going on, okay? The innermost thing here is 9/41, right?
Yeah.
9/41 is my input, okay? 9/41 is the original input for my innermost function. My innermost function is cosine inverse, right? Okay? So what we need to know is that 9/41, if it's a cosine inverse, that 9/41 physically is a ratio of the adjacent side divided by the hypotenuse, correct?
Yeah.
Okay. So when I look at my triangle here, okay, and now this is positive, so this cosine is either going to be in the first or fourth quadrant. We're going to make the assumption of first, especially with the picture they give me here. Okay. The adjacent side would be 9, and the hypotenuse would be 41, right?
Yeah.
Okay. If I use the Pythagorean theorem,
40.
this becomes 40. That's a Pythagorean triple. Probably one that we're not accustomed to, but it is one. Okay. So that is producing. So this thing here, remember, your cosine inverse, if you input a ratio, this output is an angle, right? Does that make sense? And the particular angle that we get here is theta. Everybody on the same page with that?
Yeah.
Now, we actually have enough stuff here to actually learn what theta is, what degree it is, but I don't care, okay? Because that's not the task at hand to find theta. It's to find the sine of theta, okay? So now that I've got this picture, this red function, purple function, pink function, whatever we'll call it, whatever color that is, produces as an original output, or the first output, it produces that angle and the triangle that is attached to it, okay? Then if I try to figure out what the sine of that theta is, What is opposite theta? 40. What's the hypotenuse? 41. Okay. Now, if you took your calculator, okay, and this is going to demonstrate my argument earlier to Blaze. If I take sine, arc cosine, or cosine inverse of 9/41, it gives me that number right there, right? And Desmos, I don't know if your calculator will do this. You can go fraction key. But Desmos will toggle back and forth between the decimal version and the fraction version, right? So that does all the work for me, right? Okay. But I want us to understand, okay, what is really happening here real quick before we go on. If I go arc cosine of 9/41, okay, now this is in raised, let's put in degrees. That means that this angle that we're putting in there is 77 degrees. Does that make sense, everybody? That means in that picture that I had, this angle right here, where this, I know the image is gone, let's put that image, so that theta is actually 77 degrees, okay? I don't really care about that, okay? But if it is indeed 77 degrees, and now I'm just call that value A, and I ask this thing to evaluate sine at 77.31 degrees, it gives me that. And if I toggle it to a fraction, then it's 40/41, right? Okay. I don't necessarily like showing you the calculator there because I don't want you to get ingrained in using it, because the question that shows up on a test is something like this. And there's a couple in our assignment towards the end that are like this as well, okay? So everything we just did with numerical values is going to be the same exact thing here when we use algebraic values or algebraic expressions, but it's not as easy as just grabbing my calculator and my calculator do it, because your calculator doesn't have an algebra solving system on it, so it won't do this. It won't know what to do. So this is how we do it. Okay, I'm gonna write sine, okay, of cosine inverse of, okay, this is where I'm going to pause and think about what that x represents. And remember, it's the input of the arc cosine, or the cosine inverse. And the input on your inverse function is always a what? It's the side length. It's a ratio. So here it's a ratio, and it's adjacent divided by hypotenuse again, right? So what is my hypotenuse here? One, right? It's not, it's implied, right? Okay. That's where a lot of people just kind of stop with this question, because they don't know, or they don't remember that we put it over 1, and that is actually my hypotenuse, and they can't garner a picture from this information then. Now, I kind of skipped over this. If we read the directions here, it says that x has to be from -1 to 1. And that hopefully just makes sense to us, because my domain for the cosine inverse, one of those, that question number 2, talks about this. I'm only allowed to put numbers in here between -1 and 1. Because if I put a number bigger than 1 in here, or smaller than -1, that would ultimately tell me that my adjacent side is longer than my hypotenuse, and that can never happen, right? Does that make sense? Okay. So that -1 to 1 is just saying you're going to get a defined answer. If you remember back to composite functions, we talked about in order to work a composite function, I have to have in my innermost function a domain that exists. So for instance, if I had something like this, if I had like f of x is equal to x squared, and g of x was equal to, I'm just going to say, root x here, and I ask you to find f of g of -3, well, that means I got to go to g and plug in -3 right there, right? Yeah. But for my real numbers, is g defined at -3? Does Does the square root of x, can I take the square root of negative 3 for the real numbers?
No.
No. Okay? So therefore, I can't evaluate f of g of negative 3. Does that make sense?
Yeah.
So that's why they're telling me that negative 1 to 1 is because my innermost function has to be defined in order to then take the sign of that innermost function. All right, so it's given me this picture where we've got the adjacent side is a positive number, the hypotenuse is a positive number. Okay, so remember cosine inverse is only going to give you stuff out of those two quadrants. So in order for it to be positive, I know I have to be in quadrant 1, right?
Yeah.
Okay. So the adjacent side is x. The hypotenuse is 1, right?
Yeah.
If I just call this b, can I say b squared plus x squared equals 1 squared, which is 1?
Yeah.
So then would b squared equal 1 minus x squared? And then b would be the square root of 1 minus x squared, but then it would be positive, right? Questions on that? We good? Okay. Okay, so now, remember that stuff right there, this here, is going to provide an output of an angle. And that angle that it provides is that one right there. So now I can change this to sine of theta. And what is the sine of theta here? It's opposite over hypotenuse. So that root over 1, which is just obviously that root, right? Does that make sense? Okay. Now I want to demonstrate how we can use our calculator to check ourselves.
Is that what we were typing in?
Yeah, so on my calculator, I'm going to type, so what we started with was sine of our cosine of x, right? And if I'm in Desmos or GeoGebra and I use the variable x, it's going to graph it. Anybody know what that is?
Semicircle.
That's a semicircle. Okay? And maybe if you remember back to like Algebra 1, I know in my Algebra 1 course, Mrs. Cole taught this, working with circles, you had to type in like y1 and y2. With your circles, you had to type in a square root of 1 minus x squared.
I remember that.
Okay? And you also had to type in negative square root of 1 minus x squared. And that would give me my complete circle, right? Okay? Now, obviously, we're not worried about that in this problem. But if I type those two things in, this is what I started with. This is what I found it to be equal to. Are they the same?
They are.
Yeah. Okay? Or, if you want to do it this way, put an A there, ask it to create a slide. Now, here's the thing. It said A, the input, I guess in the problem it was calling it X, had to be between negative 1 and 1. So I'm going to set the slider to be that. And now no matter where I stop my slider, it evaluates at 0.317. Do these two numbers equate? So I know that I've got, no matter where, the right thing. Okay? Let's see what happens when I go outside of negative 1 to 1. Let's go to
Undefined.
and the reason it's undefined is because when I put a 7 in there, that graph is not, or that function is not defined for a value of 7. So it sets back at undefined, therefore sine of undefined is obviously undefined. Okay? Yes?
So the answer is just going to be the missing side.
No. And that problem, but what if let's do this next one. Let's go tangent of cosine inverse of x. Give myself some room here. Tangent of cosine inverse of x. Still the same picture, right? Because cosine inverse of x over 1. Cosine inverse is going to give me something positive in the first or second quadrant. Okay, cosine inverse only gives me something between those two quadrants, but it's positive only in this quadrant. So I know if that's x, that's 1, and this would be the 1 minus x squared, right? This is theta. Huh? It's the same. All I'm saying here is isn't this part right here, what we just did, the same as that right there? No, because what if I gave you the input was 2x? What if I gave you the input was 3x? What if I gave it to you as x over 5? What if I gave it to you as r? You have to, the way I found this distance here is I used the Pythagorean theorem. Okay? Now, all I'm saying is just for the sake of the problem, there's two problems in this example, but they both have this innermost function as cosine inverse of x. Okay. So I've already done that picture once, right? I'm just cut and paste and put it over here. But if it was a new value there other than x, I would go through the Pythagorean theorem to find the missing side. But now, when I go, so that's going to give me that theta. So it's going to turn into tangent of theta. Okay, well, tangent is opposite over adjacent. So now I get that ratio. So tangent of cosine inverse of x is actually equivalent to root 1 minus x squared over x. Okay. Now, the benefit of this kind of stuff, and just kind of foreshadowing into a calculus concept, there will be a point in calculus where we want to find, we either want to find slopes or we want to find areas for functions like this. So I might take that circle, that semicircle, and I want to find the slope of that semicircle at different spots. Or I might want to find the area underneath that semicircle. Okay? It's very difficult to do it with this trig information this way. Does that make sense? But what does this equates down to that right there, right? This is no longer trigonometric, right? There's no sine, cosine, or tangent in the root 1 minus x squared over x. So when I want to take the derivative of something, it's much easier to maybe take the derivative of that thing on the right-hand side than it is to take the derivative of tangent of cosine inverse of x. Does that kind of make sense?
Yeah, that makes a lot more sense.
Okay. So that will be the benefit of using this stuff next year or whenever you decide to take calculus. Trying to remember what the last class did. Here we go. I want to do this example. Okay, and I want to change this number here to 360. Peyton, you awake? Oh, resting your eyes? Okay. Sine of theta equals 0.4. Okay. I want to solve for theta. Okay, between 0 and 360. Okay, remembering. Okay, this theta is locked in there, right? I can't get that theta out until I use an inverse. It's much like this. If I had x squared equals 5, I can't do anything with that x until I unlock it with its inverse, right? So I square both sides and I get x to be 25. Here, I can't get that theta out until I unlock it using the inverse. Does that make sense? So I'll take the inverse of the left-hand side. Okay. Sine inverse of sine, those are inverses. Okay. And if my theta is between negative 90 degrees and positive 90 degrees, or negative pi over 2 to pi over 2, there's going to be a complete cancellation there. These are going to wipe away, and all I'm left on the left-hand side is theta, right? Okay. That was the purpose of using the inverse here. So I get theta on the left, and what I'm left with on the right is sine inverse of 0.4. Okay? Now, here's the only thing. If it's sine inverse of like a number like 1/2, I automatically know that that's 30 degrees because it's the opposite over hypotenuse of a special right triangle. If I have sine inverse of radical 2 or 2, I know automatically that's 45 degrees. If I know it's sine inverse of radical 3 over 2, I know automatically it's 60 degrees. Okay, just because of the linking between those special right triangles and the ratios that we've seen a lot so far. Okay, but remember, 0.4 is a ratio, so it's like 2/5. Does that make sense? 2 over 5. Do you know a special right triangle that has an opposite side of 2 and a hypotenuse of 5?
Yes.
You do?
No.
No. Okay. You don't know what the angles that couple with that, right? So what we have to do right now is use our calculator.
Yay.
Okay. So if I'm going to evaluate this.
What did you change in 180 have to do with it?
I'll explain that in a minute. Sine inverse. So I'm going to arc sine of 0.4. Gives me that number right there. Okay. Now, no matter how many times I type that in, and this obviously this is kind of stupid to even have to talk about, but if I had to type that in again, am I going to get anything ever different? No. Okay? But there is another angle that when evaluated with the sine function still gives me 0.4 back. And that's why I changed this to 360. I didn't really have to for the sine one. But there's another angle. Think about this. If the angle that I'm dealing with is 23 degrees, so let's say that angle right there is 23.57 degrees, right? Okay. And that would be a situation where this is in a ratio opposite to hypotenuse of 2 to 5, right? Is there a triangle over here that also has a 2 to 5 there? Positive 2, positive 5, right? Okay. Now that triangle would be, okay, now it's because of, you guys remember back into geometry, hypotenuse leg? That hypotenuse is congruent to that hypotenuse, that leg congruent to that leg, so that means these two triangles are the same. Does that make sense?
Yeah.
That means to me that this angle here is what? 23.57. Okay? Theta is either that angle there or that angle there. Does that make sense? Your calculator is only ever going to give you that one. It's only because remember what sine inverse does is it only gives back angles that are in those two quadrants, right?
Yeah.
This purple one is not in either of those quadrants. So calculator is not going to give that back. Okay? But I still need it. Okay? So here's my question. How do I use this? That's terrible. How do I use this angle here of 23.57 to get this bigger angle here that we can also call theta? 180 minus 23.57. Okay? So here's how I'm going to do it, just to prove a point so I don't have any rounding issues. I'm going to call this value here A. Can I then say 180 minus A? And 156 is that second angle. Does that make sense? So here's the thing. I'm going to call that B. Okay? So when I say sine, when I type in sine A here, it's really typing in sine of 23.57. It's putting that number in there, right? Did it give me 0.4? Okay. When I type in sine of B, it's really putting that number right there in. Did I get 0.4? Yeah. But when you use the inverse function key, your calculator will never, ever, ever, ever give you that 156 because the output for the sine inverse only goes from negative 90 to positive 90. 156 is not in there. Okay? So we have to use this process. Now, here's the thing. What we're learning here, we're learning these building blocks to be able to do more applicable, more story-like, more real-world-like problems later on, and solving equations later on. Every single one of those problems that we involved in equation, a trigonometric equation, in 4 or 5 weeks, the last step is to do what we just did. Okay? We might have to use factoring like we got from college algebra, use substitution, whatever. And when we're done, we're going to get two answers, maybe from use substitution or whatever, and in both those answers, we have to do this process, because your calculator is only going to give one result out of both those answers. So eventually you'll have four total solutions at the end of the problem.
Wait, so why do you need both of them? Like your calculator gives one. Is it because it's going to ask for both? Or is it like...
It's because there are two angles. There are two angles that evaluate to give me 0.4.
Yeah.
There are two angles out of 0 to 360 degrees. There are two angles that the opposite side divided by the hypotenuse of those angles will evaluate out to 0.4. My calculator, because of the nature of the inverse, because it had to be 1 to 1, so I had to restrict its domain, is only going to give me the one that is in one of those two quadrants. We have to find this other one that is sitting out there that our calculator doesn't know about, but because we understand the way we've developed this with the potential of going from, the sign is positive in the first and second quadrant, so I can have a 2 to 5 ratio in the second quadrant as well as the first quadrant, I have to be able to find that second angle. The calculator can't do that. You're going to see, right now, I understand, first time seeing that might be something that is confusing to us. We will see plenty of those. And my hope is that eventually something that I say to you, because I'm going to keep repeating kind of the same process over and over and over again, same comments, same statements, hopefully maybe eventually it sinks in. I understand because, I was in your situation. I was in your seats at one point, and all this stuff was getting thrown at me, and it's completely new. And I didn't take time to investigate the relationships so I could do the work, but I didn't really understand what we were doing and what it was meaning to us, okay? I want to make sure that you can, one, do the work, but paramount to that, I want you to know why you're doing that work, okay? Why do I have to go find that angle of 156? And it's because when I evaluate sine of 156, it still gives me 0.4, just like sine of 23 gave me. Keep working. We got a little bit further in last class. Not much. We just talked about the law of sines real quick, and we're going to do that tomorrow again. Keep working on that assignment 5.3, 5.4. Potentially, maybe won't have class tomorrow. Got a winter weather advisory right now. Okay. If need be, I could push that assignment back to Monday if we end up not having class tomorrow. So
we might not have
it
Friday too.
No, we're having it for Friday.
They're talking about.
No, we're having it.
Register for the ACT.
Oh yeah.
No, you don't. When's Wildcat?
Like
When's Wildcat time?
Oh yeah.
Are you gonna take
You guys make fun of me.
I'm about to take calculus to this high school credit. Like Jim most of that.
We make fun of you because
I think that's a phenomenal idea, but
I don't know what I'm doing on. What if I'm gonna need it?